Start section 10.6, let's review a little bit. 10.5, we looked at permutations, and permutations is when order matters. So what that means is ABC is not the same thing as BCA. They're counted as two separate things. One example is what is the number of different ways 6 people can finish a race. And to figure that out, we can either do 6p6 or 6 factorial, or if you think about it, we have a first, second, third, fourth, fifth, and sixth place. 6 people can finish in first, and then there's 5 left for second. 4 times 3 times 2 times 1. So these are all equal, and these are examples of permutations where order does matter because it matters if you're first place versus sixth place. Another example is what is the number of different ways 6 people can finish in the top 3 spots? All right, so for this one, if there's 3 spots, 6 people for the first, 5 people to choose from the second, and 4 people to choose from for the third. Or, out of 6 people, it's a permutation. You choose 3, and the answer for that is 120 ways. The answer for the top example was 720 ways. So those, that's what we went over in section 10.5, permutations where order does matter. So today we're going to look at something different. I think there might be one more example of permutations. Yep, one more example of permutations. What are the number of different ways that you can arrange the letters in the name Christina? Okay, so to do this right here, it's the letter one. We're going to look at the number of total letters. We're going to divide that by anything that's repeated. All right, so for Christina, if you count how many letters there are, there's 9 letters. And the I is repeated twice, so we're going to divide by 2 factorial. So if you type that in your calculator, it's 181,440 ways you can rearrange the letters in the name Christina. Let's do another example. One that has more repetition besides the I. So if we look at Mississippi, alright, so Mississippi right here, if we count how many letters, there's 11 letters. But then we have a couple letters that are repeated a couple number of times. The I's are repeated 4 times. The S is repeated 4 times, and the P is repeated twice. So we have 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. So when you type that in your calculator, you might want to put this in parentheses. The answer is 34,650 ways. So we can practice typing that in. So we have 11, and then if you go to math, go to probability, and factorial is number 4. Divided by parentheses, 4 factorial, 4 factorial, 2 factorial, alright, and there's the answer. Again, 34,650 ways you can rearrange the letters in Mississippi. Okay, so that's permutations when order does matter, when ABC is not the same as BC, when those are counted as different things. Today at 10.6 we're going to look at combinations. Combinations is when order doesn't matter. So, for example, if you order fries, a drink, and a burger, that's the same thing as getting a burger, fries, and a drink. So order doesn't matter. So here ABC is the same as BCA. Okay, so combinations, order doesn't matter. Let's do an example. Let's say Alex, Ben, Chandra, and DJ are running to be the leaders of a committee. There are only 3 spots available. How many different 3-member committees can be formed? So here it doesn't matter what order you choose the 3 people. They're all working together. There's not a president and a vice president or so on. They're all on the same level. So here order doesn't matter. It's a combination. So we could make a list or a diagram. So we could do, how about we'll start with Alex, Ben, and Chandra. We could do Alex, Ben, and DJ. We could do Alex, Chandra, and DJ. And we could do Ben, Chandra, and DJ. And I think that that's all the different ways we can do it. And again, order doesn't matter, so A, B, C is the same as CBA. So here there's 4 ways you can organize this data. Like in permutations, there's also a formula for combinations. So you can use the NCR button on your calculator, where N is the total and R is the number you're choosing. And the formula that your calculator actually uses is N factorial over N minus R factorial times R factorial. So if you have a graphing calculator with NCR, that's programmed into your calculator already, but if not, you would use this formula right here. So let's practice this. Combinations when order doesn't matter. So let's say you're making an omelet. There's some non-meat toppings and some meat toppings. How many different omelets can you make with 2 non-meat toppings and 1 meat topping? Okay, so let me grab my pen here. All right, so non-meat toppings, there's 6 total. So if we're looking at NCR, it's a combination. Again, it doesn't matter what order you pick the toppings. So again, combination. So there's 6 total, and we're choosing 2 for your non-meat toppings. And then with our meat topping here, there's 4, and we're choosing 1. And then we're going to multiply these together. Okay, so if we type this in our calculator, let's try this. Okay, so we're going to get 6. Go to math, probability. You're looking at NCR, which is 3. So 6 out of 6 you're choosing 2 times, out of our meat toppings, we have 4 meat toppings. And we have combination again, so NCR. And we're choosing 1. Alright, so there's 60 different types of omelets we can make. Okay, so this is a combination when order doesn't matter, 60 omelets. Let's do another example. If you can get at most 3 toppings, how many different omelets can you make? Okay, so if you can get at most 3 toppings, you can make an omelet with 0 toppings. Plus you want to add the ones with 1 topping. Plus you want to add the one with 2 toppings. Plus you want to add the omelets with 3 toppings. Okay, so for 0 toppings, it's 10 total toppings. There's 6 non-meat, 4 meat. There's 10 total, and we're choosing 0. Plus out of 10, we're choosing 1. Plus out of 10, we're choosing 2. Plus 10, you're choosing 3. All right, so you can type this in your calculator. Ends up being 1 plus 10 plus 45 plus 120. So if you're trying to order an omelet with at most 3 toppings, there's 176 different omelets that you could choose from. Okay. Let's do another practice problem. How many ways can 2 co-chairs be selected from a class of 20 students? So again, co-chairs, doesn't matter what order, so it's a combination. So out of 20 students, you're choosing 2. You can type that in your calculator, and you get 190 ways. All right, so that does it for combinations. Here's your assignment, so you can get started on that.